Assalamualaikum. So today I'm going to present the sixth agenda about our group, which is first part is about the introduction, continue with the problem statement, objective, data and data processes, selected data algorithm, and lastly about the result. Nowadays, there have been significant increase in the number of internet customers, which lead to the boost in online communication network. Many users are now able to go online and share their thoughts and discuss with others in real time. It becomes crucial for social media network businesses to make sure their site is free from toxicity in order to promote the free exchange of ideas and opinions. However, the rapid growth of online platforms has contributed to an increase in hate speech and bullying incidents. This incident not only prevent from users share their idea openly, but also spread negativity that can affect one's mental health. The objective of our project consists of three parts, which is firstly is to identify and filter comments with harmful, abusive, and offensive language over the internet. And the second objective is about to promote the awareness and educate the society about the misuse of toxic language. The third objective is to create a positive online environment that encourage the productivity and civil conversation among the internet users.
For your information, we have 24,783 dataset of head comment and speech. Now, let me pre-process the data before we mining it. My name is NAJIHAH, so I will present about the pre-processed text. This picture shows the workflow in Orange software for the pre-processing text. Corpus used for us to upload our dataset. Corpus viewer enable us to view our raw dataset. Word cloud to show all the frequencies of all words that have in our data, include numbers, emoji, punctuation, and so on. And to remove and get rid all the unnecessary words, numbers, and unrelated words, we use pre-processed text. This is the word cloud before we apply the pre-processed text. The more frequently the word appears in the text, the larger the word will be. So as you can see, it includes all the words, including punctuation and uninformative words such as HTTP, what, numbers, and so on. Now, we apply the pre-processed text. So the first one is transformation. Transformation used to manipulate the text data to enhance the quality. So, in our project, we tick all the boxes. First, we transform all the text into the lowercase and then remove accents to remove all the accents in the text, such as knife. It will remove the I symbol, and then next parse HTML will detect HTML text and parse out text only, and last it remove URLs will remove URLs from the text. Next process is tokenization. So tokenization is a process of breaking up the text into separate tokens, can be individual words, phrases, or whole sentence. For example, I hate you will be tokenized into the token I hate and you. So in our project, we choose RegXP. I'm not sure how to pronounce it, but it will split our sentence into a tokens or words and omits any punctuation. So it is the easiest way to tokenize than other choices. After that, filtering. Filtering is the process of removing or keeping a selection of words. It is used to eliminate the special characters, symbols, and non-alphanumeric characters. For example, we remove numbers, names, and symbols such as commas and emoji from our dataset. So in our project, we tick stop words and numbers. By selecting English, it will remove stop words such as and, or, in, and more regarding the data in English. And also, we customize our own stop words such as I, us, should, could, and more in our text pad that we imported it as a files. As you can see, tweet.txt there. Also, we tick on numbers because to remove all the numbers from our dataset. Last process for pre-processed data is stemming or normalization. It is the process of reducing words to their root form. This is to normalize the variations of words, so it will have the same stems that will be treated as an identical. So for example, let me, it will let me, it will change to let me. Another example is I've always loved cat, it will change to I have always loved cat. So in this project, we choose Porter Steamer where it applies the original Porter Steamer. For example, it will convert, like I said before, let me it to let me. It is the simplest way and easiest way. So we just tick on Porter Steamer. So this is the result after we apply the pre-processed text. We only have informative word related to our project in the word cloud. So we don't have numbers, punctuation, and so on. So that's all for the pre-processed text. Let we move on to another section.
Now, me, ALYA and YUSRA will explain about the selected data algorithm that we decided to use for our project, which is sentiment analysis. In this section, I will explain about the workflow of our project using Orange software. So firstly, we import the raw dataset of hate comments on the Twitter using CSV file import. And then we connect into data info and corpus. So data info is used to display information of the raw dataset. And corpus is for loading a corpus text of documents tagged with categories or changing the data input signal to the corpus. And then we connect into three parts. 1, 2, 3. So firstly is corpus viewer. So corpus viewer is to display corpus content. And then the second part is pre-processed text. So pre-processed text splits your text into smaller units, filters them, runs normalization, and creates anagrams and tag tokens with part of speech labels. So this part here has been explained before by NAJIHAH. And then we connect into the word cloud. So word cloud generates a word cloud from corpus. So word cloud is an excellent widget for displaying the current state of corpus and for monitoring the effects of pre-processing. Okay, this part here is the data pre-processing. So, and then after that we connect into sentiment analysis and word cloud. So we connect another word cloud widget here to observe the differences between before pre-process and after pre-process. And then we use sentiment analysis for the selected data algorithm. So YUSRA will explain this section in the next part. Okay, so and then after that we divided into two parts. So the first part here is where we wanted to observe the heat map. So before connect with the heat map, we need to connect three nodes before. So firstly, we connect into the data table. So data table displays attribute value data in a spreadsheet. So for this project, we have three attributes, which are hate speech, offensive language, and neither. And then we connect into the select column. So select column is a manual selection of data, attributes, and composition of data domain. So we select the most important columns that we want to observe. And then we connect into the data sampler. So data sampler selects a subset of data instances from an input dataset. And then finally we connect into the heat map. So plots a heat map for a pair of attributes. So this is the results of our project. Humairah will explain the result of this heat map in the result section. And then for the second part. So the second part here is to view the data after mining.
Assalamualaikum. My name is YUSRA IQLIMA. Next is the data algorithm used is sentiment analysis, which is already a built-in function in Orange. This is used to evaluate the sentiment within the document, and it also will create features according to the sentiment it already gathered and analyzed. Such sentiment is positive, negative, and neutral. It can then be classified into classes. So for example, a positive sentiment will make the comments we have gathered into to be a neither category. And if it's a negative, it's going to be either a hate speech or offensive language. After the sentiment analysis, we then go into the select column, where here we choose what features to keep and what to ignore. The features kept can then be visualized using the heat map. 3 features are chosen here, which is the offensive language features, the hate speech features, and the neutral features. We then put these features into the heat map so that we can see the distribution of each of these classes according to the document that we have gathered. Then we can classify each of the data into these 3 features that we have chosen. Next, we move on to the heat map, where we visualize the data according to the features that we have chosen before. In heat map, we are using k-means to classify the data into groupings, or in another word, into clusters. The color refers to what the class the data is in, where the blue color is referring to the offensive language, the green color is referring to hate speech, and the yellow color is referring to neutral or neither class. The result will be according to its color gradient. We will see the heat map and see the gradient color of the average of this data, and we will classify it according to either it is offensive language or if it's a hate speech or neither. The result will be explained more by my friend later.
So we move on to the data analysis, which refers to the dataset used in this project. So we have 24,000 instances in the dataset, and we also have 3 numerical features used for the analysis, which are hate speech, offensive language, and neither. So the target variable consists of different categories or classes, and the metadata in this dataset is described as string, which means that it contains textual information. So next, the tokens represent the individual words. So in the information provided, it states that there are 237,000 tokens in the dataset with 35,000 unique or distinct words, and the dataset is in the English language. So the heat map uses a color scale to represent the values in the cells. So as we can see from our heat map, the color ranges from dark blue to yellow. So dark blue cells indicate instances where the text does not contain any hate speech or offensive language. And as we move from dark blue to lighter shades of blue or towards other colors such as green or yellow, it indicates increasing severity or the presence of hate speech and offensive language. So the intensity of the color indicate the degree of or the frequency of such harmful language. So yellow in this case is the brightest or the most intense color, which represents the highest or the most severe category. So in this case, it indicates instances where the hate speech or offensive language is present. So after applying the k-means algorithm, each instance is assigned to one of the key classes based on its similarity. So note that in this diagram, the horizontal line on the left represents the average color, which indicates the level of severity of the comment. So as we can see from the first line, both hate speech and the neither category are dark blue, while the offensive language is in a lighter shade of blue. So the average color is still dark blue, which means that the comment is not harmful enough to be categorized as either hate speech or offensive language. And we can take another line as an example. So the fourth line, it shows that the level of offensive language in this comment is very high and severe, which contributes to the yellow average color of this comment instance. So as a conclusion, this analysis could help validate the effectiveness of our hate speech detection model. So these patterns will provide insight into the characteristics and context of hate speech instances, and thus the information will contribute to raising awareness about the presence and impact of hate speech, content filtering, and the policy development.
Instead of throwing shade in the virtual reality, let's bring the sunshine of peace and fill the world with the rainbows of harmony. That's all from us. Thank you for watching. Bye bye.